So what's up, Year 11? Today I want to talk to you about this question. At first glance it would appear to be radioactivity, but in reality it is electromagnetism. So it tells us that we've got alpha particles, beta particles and gamma rays, and that they're travelling left to right across the page. A magnetic field acts perpendicularly into the page. So we're going to take a look at how we figure out what happens to each particle. Alpha's been done for us, but we'll do it anyway just to make sure that we know how it was done. So we know that the alpha particles are moving from left to right. So let's draw an arrow in there representing the alpha particles moving left to right. Now alpha, of course, is made of two protons. One proton there, one proton there, one oh, that's a proton again. There we go, get there eventually. And we've got, there we go, there's our alpha particle. Okay, two protons, two neutrons. Now the charge on it, can you think what the charge is? It is, of course, +2. Okay, so that +2 charge is moving from left to right. So think about which direction the current is in. Okay, so giving you a second to think about that, the current should be this direction here. Now the reason for that, there's I for the current. The reason for the current being in that direction is that we know that conventional current flows positive to negative. So negative would be over here, which is why the positive particle seems to be attracted towards that direction. We can also draw a quick X to represent the magnetic field going into the page. And so if you stick your magnetic field, that's your index finger, into the page, the current, your middle finger, going from left to right, you should see that the force goes upwards towards the top of the page. And so that's why that's correct. Now what about this small deflection here? Why is that a small deflection? Well, the reason is that alpha is very, very heavy. It's like sort of 4 nucleons, isn't it? 2 protons, 2 neutrons. They're very heavy particles, so because they're heavy, it's a small deflection. You know, think about it, the fact that something's heavy, it's harder to move. Let's go on to beta particles now then, and I can draw out a small beta particle for us. We'll stick with, in fact, let's make that brown. Now, of course, a beta particle is just an electron. So the electron is moving in the same way from left to right. So let's draw that on there. That's the direction that it's actually moving. But because the charge on the electron is not the same, it's -1, the current is actually not flowing in the same direction. The current is flowing from right to left. So we can label that as I. There is the current flowing from right to left, because we know that conventional current flows positive to negative. So this negative particle, if it's flowing that way, that must mean the current is flowing that way. Again, our magnetic field is still into the page, so using Fleming's left-hand rule, we can say that the current is to the left, the magnetic field is into the page, and that gives us, wait for it, deflected towards the bottom of the page. Now it's a large deflection, and the reason for that is the electron is very, very light. So for the same force, it moves a long way. Notice that you could have quite simply figured this question out, because the charge has been reversed, therefore the deflection also gets reversed. That's why they do this first line for you. You don't actually need to do Fleming's left-hand rule here, but you might find it useful. Finally then, we've got gamma rays. Now gamma rays are not deflected. Think about why. They have no charge. So if there's no charge, there's no current, no deflection. And so there's no large, no small deflection, there is no deflection. That's how you'd get 3 marks on that section. Next then, it says an electric field is now applied. So an electric field is applied. It's the same region as the magnetic field, same time. What direction do we need it to be to cancel out the deflection of the alpha particles? So let's look back up at this one here, put a box around it so we know we're looking at it. Let's look back at this. We know that the force is going to be upwards. Now if you want to move an alpha particle downwards, which direction do you put the electric field? Well, the answer is down. Now why is that? Well, because the electric field lines represent the direction of the force that a positive charge would feel. So if our positive charge is being picked up and it's going upwards towards the top of the page and we want to pull it down, then we need field lines downwards to provide a force down. So the magnetic field pushes it up and the electric field pushes it back down. So our answer to that is the electric field needs to point downwards. Hopefully that's all clear. That's a full 5 marks for both of those questions. If you've got any questions, leave them in the comments or ask